Your learning journey starts now. Ever wondered how your brain conjures up the feeling of seeing red? Or why a machine can beat you at chess but not truly feel? We're diving into the electrifying frontier where brain science meets artificial intelligence, peeling back the layers of consciousness itself. So, how do we peek inside that complex organ? We've got an arsenal. Think EEG and MEG. They're like super fast cameras capturing the brain's electrical chatter in real time, down to the millisecond. Then there's fMRI, mapping out which brain neighborhoods light up when you think something profound. And for the nitty-gritty details, optical imaging lets us watch individual neurons dance. The ultimate tool? Brain-computer interfaces, or BCIs, directly linking thought to action, reading minds, even writing intentions back into the brain. It's like having a direct hotline to consciousness. Now, all this data is great, but how does it make sense? Enter the DIKWP model. Think of it as a cognitive ladder with 5 rungs: data, information, knowledge, wisdom, and purpose. It starts with raw sensory input, data. Your eyes see light, your skin feels heat. Then, your brain extracts meaning, information. That flicker becomes a bug. That warmth becomes a cup of coffee. Next, you build understanding, knowledge. You know bugs are food, coffee is caffeinated. Then comes judgment, wisdom. You decide to catch the bug or sip the coffee. Finally, the grand prize, purpose. Why are you doing it? To survive, to enjoy, to achieve a goal. This framework isn't just theory, it's the blueprint for building smarter AI and understanding our own minds. So, how do we use this? First, we see the brain using those fancy imaging tools we talked about. We map out how it processes information across all these DIKWP layers. Then, crucially, we recreate the brain. Using the DIKWP model as our guide, we design AI systems that mimic this layered process. It's not just about raw computing power anymore, it's about structure and semantics. Take the DIKWP AC system, for example, a relatively small AI that uses this model to perform complex tasks like medical diagnosis with surprising clarity and explainability. It shows that by getting the architecture right, inspired by the brain, we can build intelligent systems step by logical step from simple data to meaningful purpose. Looking ahead, this gets even more fascinating. Concepts like DIKWP times DIKWP suggest AI could develop self-awareness loops, constantly monitoring its own thinking. Imagine BCIs seamlessly integrated with DIKWP models, creating true human-AI symbiosis where we share intent and understanding. This leads to white box AI, transparent, explainable, and fundamentally safer. But the big question lingers: can machines truly feel? Maybe the journey of understanding consciousness, both in ourselves and in machines we build, is the most exciting part of all.